here for this week and also for next Friday. So there'll be a follow-on session on Friday to cover some of the open ignition troubleshooting discussions and some of the tools around that, some of the ancillary products around the ignition topic here. Two of our veteran fieldmen, Mike Porter and Paul McHenry here, are carrying the discussion both days, and we'll focus today primarily on the detonation detection systems, how those are set up and interfaced with the ignitions, as well as the companion product that's a general vibration sensing system that uses a lot of the same hardware and setup. So without further ado, gentlemen, the floor is yours, and thanks again for putting this together.
Thanks, Dave. Okay, so for this afternoon, Mike and myself are going to cover the DET 1600, and then Mike's going to cover the VSM 400 and 800 after the 1600 is over. So we've had quite a few new people and a couple of new distributors come on board. So a lot of you already know this product, and bear with us as we go through it for the new guys. So basically, the bottom of that slide there is a picture of the display for the DE 1600. So you can see it's in an annunciator style box. So it's basically a 6x6 cutout, just like we're all familiar with from the annunciators. So on the back of it, basically, I just want to go over the wiring of it. So at the bottom, you can see the two 16-pin Phoenix connectors at the bottom with the jumpers across it. So this product can take in up to 16 piezoelectric vibration sensors, and we basically are using the Bosch style sensor that you're familiar with on your cars. So most cars have detonation sensors today, so everybody's pretty much seen them at this point, but we'll cover them a little bit later. And then in the upper left-hand corner, you can see that the input power from this product is anywhere from 10 to 32 volts. So a wide range of DC voltage can power it. It pulls about 0.3, so slightly more than a quarter of an amp is all it really needs. As far as the output switch ratings, there is two output switches that we're going to talk about, and you can see in the upper left-hand corner that they're rated 200 volts at 200 milliamps. So, and then as far as the top connector, the Phoenix connector to the far left there, you can see the inputs are the first one being the number one coil input. And the second one is the shutdown lead. So that's kind of how we know where the engine's at all times. So we're looking at the shutdown lead. So if it's a 16-cylinder engine, we're seeing all 16 pulses going out to the coils. And then we're getting the single pulse from the number one coil to let us know that we're on the number one cylinder, and then it times the other 15 cylinders from that point. The next two connections there are the DC power. So that's where your 24 volts or your 12 volts is going to be connected. And then the next three is the switch. So like we just talked about, we have two switches that this product's going to be using. You've got switch 1 that's going to be used for load control, that we'll cover a little bit later, more in depth. The second switch there is used to shut down the engine in case the detonation can't be controlled. We're gonna want to kill the engine immediately to keep the engine from going into major damage mode. So it can happen fairly quickly. So we've got timers and so forth we'll go through. And then the middle connection is the common for both switches. And then the next connection there says 4 to 20 out. So there's two ways to control timing with this product. You can either use a 4 to 20 going out to your CPU or your CD200 or whatever ignition you're using, and it'll control the timing, the back off, retard the timing to get you out of the detonation. Or you can use the Modbus. So if the product that you're using, 95, 2000s, CD200s, they have Modbus capability, you can actually send that signal through Modbus and it'll change the timing and without using a 4 to 20. So you have the choice between the two. And because of that, you have to have two ports for this product. So one is going to be connected up to the ignition system, and then the other one's going to be used to program the product. And then off to the side there, you'll see the LEDs, the receive and transmit LEDs for both the slave port and the master port down below. Okay, a little bit of overview. The DET monitors for both detonation and misfire using, like I said, up to 16 low-cost Bosch piezoelectric sensors is the one we use. So it does have 16, the capability to do up to a 16 cylinder, but obviously if you have an 8-cylinder engine, this product can be put on anywhere from a 2 to a 16 cylinder engine, and you can use as many sensors as you see fit. It does provide a load reduction signal via switch 1. So when the unit does see detonation, our first choice is to back the load off a little bit to get the unit out of detonation. And then the second choice is to back off the timing and retard the timing back a little bit to get the unit out of detonation. And we'll go through that a little bit more as we talk. Retarding the timing, if detonation is sensed, is done, like I said just a minute ago, either through the Modbus signal or through a 4-to-20 signal. Shut down the engine if detonation cannot be controlled by either load reduction or timing retard. So like I said, first thing to do is back off the load to 90% to 80% to try to get it out of detonation. If that's not working, then we're going to take over the timing and start backing off the timing a degree at a time until it gets out of detonation. And we'll show you how to program that here in a minute. And then there is adapter available. Once this product first came out, it was really designed for the negative ground systems. And immediately there was a call for putting it on with CP2000s and positive ground systems. So there is an adapter to allow this product to be used with the positive ground systems.
Also, Paul, it's called a 1622. So
the 1620 is the part number for the adapter. Or the DET 1620, I see what you're saying, yeah.
There you
go. Okay, and what is detonation? So detonation is basically the disruption of the flame path in the combustion cylinder caused by the inability of the end gases to withstand the pressure and the heat. So if you've got so much pressure and heat in the cylinder, it lights off the air-fuel mix, then this plug lights off the fuel mix. You've got two high-pressure waves basically coming at each other and hitting each other. It creates a detonation that sometimes can be heard and sometimes it can't, but it basically does a lot of damage inside the engine. And the pressure, instead of seeing 600-700 pounds pressure, you might see 1,000, 1,200 pounds, or you can, break head bolts. You can do a lot of damage in literally 30 seconds. I mean, that's how quick you can do damage. So it has to be controlled, and you definitely don't want to run an engine in detonation. Now, we're going to talk about incipient detonation a little bit later, so I'm going to just talk about that just for a second here and let you know what it is. So incipient detonation is just very light detonation, and you may not even hear it. It's so light, but this sensor is so sensitive. The sensor will put out anywhere from 0 to 26 millivolts, depending on how much vibration it sees. So even if you just tap it with a pencil, you'll see the bar graph, on Mike's demo here. It'll go right through the roof. So it's very, very sensitive piezoelectric sensor. So when we talk about putting a unit into incipient detonation, that's what we're trying to do, is just to get the unit to go into real slight detonation without doing any damage, without making the customers nervous. So that's something that we're going to talk about here in a few slides. Okay, and then the input-output structure, the set points. The detonation is considered a high set point. So when you put the unit into detonation, it goes past whatever set point you are. In the right-hand side there, it's showing detonation about 700. If your set point was 750, if that goes up past 750, it's going to first trip switch 1 there on the right-hand side, and that's going to be connected up, or hopefully connected up to load control, and it's going to start backing off the load of the engine to get that unit out of detonation. And if that does not get it out of detonation, then basically it's going to start to retard the ignition secondly and back it off from, say, 10 degrees and back it off to 8 degrees and so forth until it gets it out of detonation. And Thirdly, if that doesn't get it out of detonation between the load control and backing off on the timing, then the switch 2 is going to trip and it's going to shut the engine down immediately once it sees that point. And then misfire, that's considered a low set point. So if you've got a cylinder that's running along and plug shorts out, or somebody steps on one of the wires, or the corrosion broke off the secondary wire or whatever, and it goes into misfire, this product can also pick that up also. But that's going to be considered a low set point and not something that we're going to shut your engine down over. So you can see under misfire, it doesn't do anything with switch 2 that's going to kill the engine. It's just going to give you a switch 1 trip, which we would consider like an alarm, and it's going to back the load off a little bit, because instead of running on 16 cylinders, if we're talking about a Cat 399, it's going to be now running on 15 cylinders. So yeah, the engine can still run, but you probably don't want to run it at full load, and it may even die if it's missing just one cylinder at full load. So in any case, switch 1 will back off on the load a little bit, since you're now missing one of the 16 cylinders in the Cat 399 example. And then the bad sensor, this is also considered a low set point. This is going to be up to you whether you trip switch 1 or not, and I'll show you where you pick that choice in a few slides down here. If the wires got broke or if the sensor actually went bad, you can actually pick this up with this product, and it'll tell you that, hey, you've got a bad sensor, or the wire's been broken and we're not getting a good signal. And it's going to be up to you to whether you use switch 1 to back off on the load or not. We're giving you that choice when it comes to the bad sensor. And then the installation steps, we're going to go through the step 1 is the general setup parameters, and then step 2 is going to be the input to set points and the output parameters. Okay, so you can see this is the terminal program that's on our website that you download for this product to set it up. Okay, across the top there's 7 tabs that you're going to need to click on it to set the product up. It's fairly easy to set up once you've gone through it once or twice, and a lot of it's pretty self-explanatory. So on this particular first one, general setup page, if you go to the upper left-hand corner, you see the number of cylinders. So I was talking about a Cat 399. That's a 16 cylinder. So I would take that 12 out and I'd put 16 cylinders in there. And then basically I have to know whether it's a 2-cycle or a 4-cycle engine. The product needs to know that. So in case of a Cat 399, I'd have to change that 2-cycle to a 4-cycle, since that Cat is a 4-cycle engine. And then right below that is auto scan. So like most of our products, we have the capability of auto scan. You set that up for 3 seconds, and every 3 seconds it'll go through channel 1, channel 2, channel 3. But if some customers don't want it to scan, they just want it to stay in one particular screen and move it manually between screens. And in that case, you just set that auto scan for 0 seconds, and it'll stay in one place. And then right below that, you're going to have 2 filters. So you've got a lag filter for misfire, and then you've got a lag filter for detonation. And I guess the analogy that's best for these are, this is an electronic pulsation dampener. So if anybody remembers the old analog pressure gauges where the needles would bounce around a lot, and you'd go down below and you'd adjust the pulsation dampener to keep the needle from bouncing around with the pressure pulsations, this is basically the same thing, only we're doing it electronically. So we're sampling it less often. So just for an example, instead of every half second, it might be every 3/4 seconds. So it stabilizes out the display if you're not happy with how the misfire's displaying, or if you're not happy with how the detonation's displaying. You get in here and you just tweak this number here. They go out of the factory, I believe, at 240 is what the default, I believe, is. So those two are adjustable out. And everything on this page is basically going to be something you're going to need to set up. So right to the right of that is the map sensor. So again, you have the capability of 16. If you're only going to be using 12, then you need to tell us what you're doing with those 12. So in this particular case, and common sense would tell you, cylinder 1 should go to sensor 1. cylinder 2 should go to sensor 2, and so on. And that makes sense. But basically, it's up to you to how you wire these up. Now, if you're only using 12 of the 16, then you want to leave those last 4 jumpers in, and then we're going to show you how to disable them in the programming here in a minute. So basically, tell us how many you're using, and then leave those jumpers in for the non-used ones. And then up into security, this product's got nice security capability. So you can set up, just check one of the 3 boxes. I'd recommend you check all 3. Once you set this product up out in the field, it's running right. You don't want anybody going in and moving around any of the numbers or anything, because it basically can throw everything off. So I would set the general setup, the set point protection, and the communications protection. I'd check all 3 of those boxes, and then I'd set myself up a 3-digit password there where it shows 0 in the box right now. So it leaves with no password, and we're going to leave it up to you to set up a 3-digit password once you get the product up and running and calibrated. And then right below that is the box that says timing data. And we're going to give you basically a choice of where are we going to derive the timing from. We're either going to derive it from you telling us down below it's the max advance is 10 degrees before advance. That's the max advance, 10 degrees before top dead center. Or we can pick it up through the Modbus signal. And in this example, it's going to be 30,016. We're going to go over to the ignition and constantly read that. And basically, ignition is going to be telling us where the timing is at, constantly changing. So that's going to be up to you of how we're going to derive the timing for this product, either through the 10 degrees before top dead center, and then it'll change depending on the 4 to 20 signal, or you can pick it up through the ignition, and that's going to be, again, that's going to be up to you to make that decision.
Hey, Paul, I want to add something to that. Go back
Okay.
there just for a second.
Go back.
Yeah. One thing I want to make clear on the mapping sensors, that where it says firing events, that's in the firing order. So when you start putting cylinder numbers in there, they're not going to be cylinder 1, 2, 3, 4, and 5 like it shows there. It's going to be the ones that's in the firing order. So it might be, it will of course start out with 1, but then it may be cylinder number 6 or cylinder number 4 or whatever. So make sure you know what the firing order is before you enter that information in there to make sure that everything matches when it gets up and running. So that's all.
Okay, bear with me. I'm trying to get the arrow down there so I can advance the slide. There it is. Okay. So the second tab at the top. Now we've left the general setup and we're now in the set points and the outputs. We've got to set this screen up. And the upper left-hand corner, you really have 3 set points you're going to have to adjust. The bad sensor one is really one that you don't have to mess with much. It's adjustable, but it leaves the factory right there on the left-hand side. It's defaulted at 50, and pretty much from what my experience is, you can leave it at 50. So you don't have to really mess with that one, but it's adjustable. Okay, and then the misfire set point is also adjustable. You're going to have to set that up, and I'm going to show you how to set that up in a slide or two. But this is the screen where you set the misfire set point up at 400 right now for this example. And then the detonation, you're definitely going to have to adjust that one once you intelligently do a little troubleshooting that we're going to talk about in a minute here. So that's where you set those 3 set points, but down below are the 2 output switches that you have to also program. So we've got a disable on both of these switches. You see the disable box that you can click. And the reason we put that in there is because while you're working on it, on the setup and the programming initially, you may not want the 2 switches to be tripping back and forth, shut your engine down or backing off on the load. So in this case, you can just go and disable both switches, do all your troubleshooting, and then before you once you're happy, then you enable both of these switches to do the load control and the shutdown of the engine. And obviously both of these switches can be set for either shelf state or fail safe. So you're going to have to pick one of those 2, and then you can do it normally latching or a non-latching or a latching switch. So on both switches, you have to pick those two choices. And then the switch 1 has a hysteresis time. Right now I've got it set for 3 seconds. And then down below that on the trip on the fault diagnostic, this is kind of, you have to dig around in the literature to find this, and a lot of times people don't know what this actually does. So if you click on that box, you're basically saying, I want to trip if I have a bad sensor failure. So if the wires get broke or the sensor goes bad, I want to trip switch 1, and I want to back off on my load with switch 1 if I have a bad sensor. So that's what that actually is doing. If you don't want the bad sensor to bother you or do anything with load, it's just going to come up as an S in the screen, and you'll know it's a bad sensor anyways, but I don't want it backing off on my load because my engine's running normally. Then basically you could, this is where you'd make that choice on the trip on fault diagnostic at the very bottom there. So if we move over to the right-hand side, where at the top it says control RPM value. And I put the little box on the right of that, says not armed, and basically what that's telling you is that I haven't reached 800 RPMs, so this product's really not doing anything. It's not armed. So I'm looking at all the signals, but I'm not going to do anything because you've told me to ignore everything until I get to 800 or 801 RPM. So that's the RPM that we're going to start doing. This product's actually going to start doing its job at 800 RPM. So the box right below that is the time afterwards. So once I see 800 RPMs, the magnetic, or we're now at 800 RPMs, that control lockout time will count down 10, 9, 8, and when it gets to 0, that's when I'm going to go from not armed to armed, and the product's going to be fully working. So you've got 2 set points there, 800 and then 10 seconds that you have to work with. And then right below that, you have to tell us the maximum retard you want this product to be able to move your timing, whether it's 12 degrees, 20 degrees, or what. But in this example, I've got it set for 20, and it's going to be able to move my timing via the 4 to 20 signal 20 degrees. Now, if you remember 2 or 3 slides back, our max advance was 10 degrees before top dead center. So my 4 to 20 signal is got the capability of moving 20 degrees retard. So I'm going to go from 10 before top dead center all the way back to 10 after top dead center. So that's going to be my range, 10 before to 10 after with that 20 degree set point I've got set in there. And then a retard step value. So basically, once the unit sees detonation, I want it to react fairly quickly because we want to get the thing out of detonation at ASAP. So essentially, I got my retard step value. I want it to move back 1 degree, and then the box right below that is 1 degree per second. So the product's going to move quickly, 1 degree per second till it gets out of detonation, and then it'll stop. Now, if whatever was going on goes away, it's going to the max time. Here the next box is the trip time at max retard. So once the unit gets the full 20 degrees of retard, it's going to count 3 seconds in that switch 2 trip time before it shuts your engine down. So in this case, max advance is 10 degrees before top dead center. I'm in detonation. I start backing off the timing. I get all the way to 10 after top dead center. Then I'm going to count 1, 2, 3, and the engine will be shut down at that point. Switch 2 will come into play. So that's that box with the 3 in there is a timer. So if the unit is in detonation, we back off the timing and the problem goes away, it'll start to try and advance back up to the max advance, which, like we said, in this example is 10 degrees before top dead center. And you have to tell me how fast you want to move forward. So we want to retard quickly because we want to get the unit out of detonation, but we want to advance it back up slowly. So we're going to advance, in this case, 1 step is going to be 1 degree. And then the last box at the bottom there is 60 seconds. So we're only going to move 1 degree per minute. So advance it a degree, wait a minute, see if it goes into detonation. If it doesn't, bump it up another degree, and so forth until we're back at the max advance at 10 degrees before top dead center in this particular example. So the last box on the bottom there is you can disable ignition timing if you wanted to. I'm not sure why you'd want to do that, but that box is there. Maybe if you're doing troubleshooting or so forth, the capability is there to shut it off. But this product's going to be controlling with timing and load. So you're down below, you're going to have to tell us whether you're using the 4 to 20, which I have enabled here, and you can see my loop high, my 20 milliamps is 20 degrees max retard there. So, and then the loop low is, of course, your 4 milliamp signal, and that's going to be 0 degrees of retard or max advance, and that's equated on this example at 10 degrees before top dead center. So that's where you're setting up your 4 to 20. You enable that box there, and then if not, you're going to be enabling the Modbus control in the other box, and you have to give us the Modbus 30,016, which was on the general setup page. So you have to let us know, because depending on which ignition it is, a 95 2000 CD200, the Modbus register number will be different. Okay, so steps 3 and 4 is setup of the two signal limiting parameters. So the first parameter is going to be a time-based window. So the next slide shows this a little better, but basically we're only going to want to look for detonation in a certain window of time, because there's so much noise happening inside the engine. You got chains and gears and valves opening and closing and pistons and rod slap and all kinds of stuff. So we only want to look when about the detonation should happen. And on most of these, on these engines, it's usually right around 16 after top dead center is where you're going to see your detonation. So in this example, and this is adjustable, you'll see as we go along here, the typical window is usually about 20 degrees. So in this one, we're going to set it up to open up at 5 after and stay on for 20 degrees. And so basically it's going to open at 5 and it's going to shut itself off at 25 after top dead center. Because if that particular cylinder went into detonation, it should have happened right around 16 or in that range. So basically this is something, these two parameters are going to have to set up for that window. And like I said, a slide or two more and I'll show you where it's actually set up. The second parameter is you're going to have to set up a bandpass filter. So this is a frequency. And this is going to change depending on the size of the pistons in the engine. So in the literature, you're going to find a formula. And right there where it says frequency equals 25/140 divided by the bore or the piston size, and then multiplied by 3. So in this example down below, I think I used a Waukesha engine. So I'm taking my 25/140, which is a given. I'm dividing it by my bore size, which is 9.5 inches, and then I'm multiplying it by 3. And my bandpass filter for that particular engine would have been 7939 hertz. And we're going to need that to go in on the next screen and set up our bandpass filter. So that's all in the literature. You don't need to really know anything. Just look in the literature and get that formula to set up the bandpass filter. And then lastly, you need to set up the gain and the integrator set points, and that'll be on the next screen here. Can you use the arrow keys to move forward with these, or you have to use the on screen?
No, you should be able to use the arrow keys or hit enter.
Yeah, you can use the arrow keys. Okay, good, because that's all right. So here's the window example here. So you can see the on the right hand side, you can see the blue line is the ignition spark. So in our example here, that would be at 10 degrees before top dead center if the engine was running at max advance. The start of combustion is a couple degrees later by the time the air fuel lights off. Then you start to build your peak pressure in your cylinder, and you want that to max out after top dead center, because obviously it's like riding a bicycle. You want to push down on the pedal after top dead center, or basically you're braking the bicycle. You're putting it in the brake mode. So the peak pressure should happen after top dead center, and right there about 16 after is where you see all that noise on the down slope, and that's where the detonation is going to occur on these engines. So that's why the open sample would be 5 degrees the way I had it set up in our example, and it's going to shut off at 25 after. and that's completely adjustable, but that's a good starting point. And a lot of the ones that I've seen use that 5 and 20 degree window, which opens at 5 and shuts off at 25. So, and then at the left here, windowing is used to suppress unwanted noises in the engine, such as valve openings and closings, piston change of direction, electrical noise, and so forth. There's a lot going on there, so you only want a small window to actually look at or sample that detonation signal. And these are basically called linear gauges. And this is how you set it up. And you have to use a PC to set this product up, because you're going to need to look at these gauges across the front here, the 8 blue lines. But down below, you're going to need to set up the bandpass frequency that we just talked about, the 25/140 divided by the bore size times 3. And we came up with 7939. So if, in that case, I'd go over to the left-hand side right below cylinder label, and I'd hit that down arrow key, and I'd take it from the 24 or the 5480, and I would find the 7939 hertz, and I would click on that to set up my bandpass filter for this Waukesha engine that had a 9.5-inch bore. And then once you do that, you hit the copy setup button over here to the right, where it says time-based window right above that, and it'll take that 7939 and run it across all 8 of those particular cylinders. So it makes it quick and easy for you, because you're going to use the same bandpass filter for all the cylinders, because all the bores are the same, right? The cylinder size is the same. So if you get a bandpass filter that's 7939 and you hit the drop-down menu and there's not an exact 7939 number, then you're just going to pick the one that's closest to it, is the idea there. But there's a lot of choices when you hit that drop-down menu for the bandpass filter. Then right below that, you're going to need to set the gain up. So before you start the engine, this is going to be your coarse adjustment to adjust the linear windows, or the linear gauges right above there with the blue lines. And a good starting point for these are just 1. So you put 1 in the first box and you hit copy setup, and it'll put them in all the other boxes for you. And then the integrator, that's going to be your fine adjustment. So that's going to be a time-based number, and I would say set that up for 200 as a good starting point, and then hit copy setup. Okay. Now at the very bottom, you have to enable all the sensors that you're actually going to be looking at. So there's 16 sensors. This screen only has 8 sensors on it. So if you look up above, the next tab over is sensors 9 through 16. So you're going to get a screen just like this for sensors 9 through 16 if you clicked on that tab. But so I'm going to put the check in each one of these boxes, because I'm going to be using all 8 of these, and I'm going to set them up once I get the engine started up with my bandpass, my gain of 1, and my integrator of 200. And then I'm going to start adjusting the gain in the integrator to where the linear gauges, the blue lines, I'd like to set them up around 500. You don't have to, but what's nice about setting them up with counts about 500 is the range is 0 to 1,000. So then you're right in the median range, so you're in the middle. So that way you've got maximum to descend or ascend. So, and that's pretty much the way I set it up. But you don't, basically this is going to be you setting this up, but that's how I'd recommend doing it. Up in the right-hand corner, you've got your global retard. So right now, the engine's it's in max advance, and there is no retard. So if it's in detonation and it starts to add 1 or 2 degrees, it's going to show up in that box right there. Now, any of the boxes that are not white means that they're just display only, and you can't do anything with them. So that box is showing you your retard, and then the one below that says detonation average is at 704. And that's the average of these eight detonation sensors, and that's going to be a display only also. This particular page has the detonation set point value where you can adjust it here. It's at 800. It was also on the general setup page, so there's actually 2 places that you can adjust the detonation set point value. And then down below in the right-hand corner is the Windows parameter. So you're going to open the window. In this particular example, they're going to open at 1 degree after, and then the duration is going to be 22 degrees. So this is going to open at 1, and then it's going to shut off at 23 after. So in our example earlier, that would have been 5, and I would have had that 22 degrees set at 20, so it would have opened at 5 and shut off at 25. So that's where you're setting up your window for your detonation sensing signals to be seen. Okay, so step 5 is to test and set up the misfire, detonation, and the bad sensor set points. So your misfire set point, with the engine running, you might want to reduce the load a little bit, because if an engine's maxed out or loaded up at 100%, I mean, most of us have been on engines where you pull one plug or you shut off one cylinder and the engine will actually die because it can't carry the load with missing one of the cylinders. So it's a good idea to back off the load a little bit. And then make sure the engine's above your control set point or your control RPM, or you'll basically won't be controlling. So we had that control RPM value set up at 800 in the original general setups screen. So until we get above 800, it's not in control. So you have to be above the 800 in this particular example to let the thing do its job. So once that's running, you're actually in control. You're above that 800 set point. You can either short or open a secondary lead. So basically, you're going to be killing one of the cylinders because you're either shorting it out or you're opening up the spark plug lead off the spark plug. And then you're going to note the misfire number. So if it's running at 500, and when you disconnect that spark plug wire, obviously you want to make sure that the area is safe if you're going to be pulling off that secondary. You're not creating any sparks. You're going to want to note the number. So if it was running at 500 when it was running, you pull the shorted or pull the secondary wire off and it drops to 300, then you know what a misfiring cylinder looks like. It goes from 500 and it drops down to 300 in an example. So then you know to set your misfire set point. Right now it's at 200, and we'd have to set that maybe for 320 because we know at 500 it works, and at 300 it's a dead cylinder. So we're going to set that maybe 320 or 325, something like that, so that it actually trips the misfire set point. The bad sensor set point is pretty much a given. I mean, we leave it at 50. When it leaves the factory, it's the default, and you pretty much can leave it there. An open sensor usually gives you a signal of about 30 counts. So this one here is pretty much a given. And again, you can pick whether you want switch 1 to trip when you get a bad sensor set point or not. So we talked about that a little bit earlier. Now the detonation set point, this is actually the most important. So you want to do this one right and make sure you get this one correct. The set point can be best arrived by putting the engine into incipient detonation by advancing one cylinder, we're going to call it a rabbit cylinder, a few degrees of the global timing. So again, you want to reduce the load a little bit on the engine so you don't throw this thing into major detonation. So you might want to back it off. If it's running at 100, back it off to 90 or so. And then if you're running an ignition system that has the capability of individual cylinder timing, like a 95, a 2000, a CD200, you can actually take one of the cylinders and bump it up a degree or two. So if they're all running at max advance at 10 degrees before top dead center, and you're going to take one cylinder and run it at 11 or 12, that's the cylinder that should start to go into incipient detonation, and you can start to see it. You may not hear it, but you should see it. You'll see it on the actual sensor, and you'll see it on the linear gauges, those blue gauges that we just talked about. And then you're going to take note of how high that detonation signal rises on the linear gauges. It'll show it in the blue line, and it also give you the number above it. So if it's running at 650, you put it into slight detonation, incipient detonation, and it jumps up to 800. Now you know what minor detonation signal is going to look like, and you can set your detonation set point accordingly. So down below, detonation 800, you're going to have to go in there and adjust it depending on what you just saw when you ran that one cylinder into incipient detonation. Now, having said that, we've had customers that wouldn't allow people to put their units into slight detonation, and we've also had people that were scared to do it. So in that particular the cases, what we've told people over the years is have the engine up and running, have it running at full load, and then just monitor all the set points, the detonation from all the sensors for 10 or 15 minutes, and just take note of the highest number coming off of the sensors that you ever saw. So if some of them are running around 700 and occasionally you see 750, but you've never seen anything higher than 750, now you know that you basically never goes above 750. So then you might want to set your detonation set point up at 800. So the unit never got into detonation. It was at 750. I know if it goes into detonation, it's going to jump up quickly, and I'm slightly above where it ever runs. And so that's the other way to do it. And we've had customers set them up that way also, without putting the unit into detonation. So what the screens look like. So here at the top green screen there, detonation sensed. I've got switch 1 tripped already. My load should be backing off. It's channel 1 that's in detonation. The detonation's at 725. And you see the D to the right-hand side of the screen kind of tells you that this unit's in detonation. And then if you hit the escape key and you're looking at the bar graph, it says detonation sensed, switch 1's already tripped, and you can see which of the bar graphs is actually in detonation because there's a D in the first channel. So it gives you an idea, a quick glance of what's going on and which one's causing me the problems. And then lastly, on the tabs up above, now the misfire is going to have a screen just like the linear gauges that we just talked about for setting up detonation. You're also going to have that same screen for misfire. So you're going to have to adjust those misfires up to around 500, just like you did on the detonation. So from detonation 1 through 8, 9 through 16, misfire 1 through 8, and misfire 9 through 16, you're going to have that same screen with the blue lines that show the linear gauges, and you're going to have to calibrate up the integrator and the gain until you get around midpoint of about 500 counts. So, and then the last tab to the far right there is your diagnostic tab, and up top here it's just telling you the sensor status, everything's okay. It's looking at all the sensors, the resistance is correct, everything's connected, no problems. And then the green light's telling me that I'm seeing engine rotation, and the control RPM has been reached, which was 800, so we're obviously above 800 RPM in this example. And then none of the switches are tripped because this particular one is in detonation right now. And then to the right, it's going to show you your supply voltage, which at this particular case is 24.5 volts, and it's telling me my engine RPM is at the moment is at 692. And then down below, it's going to tell you the sensor status, and if anything's tripped. And then down below, there's the LEDs for all the different signals. Your current loop, we've got a current loop, we've got a number 1 ignition coil signal, we've got shutdown link signal, and we've got communications. So this is your diagnostic screen to give you a quick glance of what's going on. Now, I pulled this out of our quick service guide, which is on our website. There's 3 or 4 quick service guides, and one of the products is the DET 1600. So if you're ever going to install one of these, it's best to just read that first because it's about 3 pages long, and it gives you a quick overview of how to put the product on, how to mount it, how to mount the sensors, and they're very, very helpful. But that sensor needs to be mounted against the block, and it has to be on a smooth surface to get the best signal out of it. Like I said, it's a very low voltage signal. It's only 0 to 26 millivolts. So what you basically need to do is it's an 8mm bolt. Usually you get a 1 inch thread on the 8mm bolt, and you drill it with that drill bit there, which is an H letter drill bit. Okay. Then you take that spot facing tool, you put it in. At the end, the pilot bit at the end of that spot facing tool will fit right into the hole nice and tight, and then you turn it with a drill, and basically now you've got a nice smooth surface. You've taken all that casting material off the side of the cylinder, and because this vibration sensor has to be across a smooth surface. So, and then once that's done, then you're going to go in with your tap, a bottoming tap, and you're gonna tap it for that 8mm thread. Now, here's the other thing to worry about is if you've got a 1-inch bolt and through the sensor it's sticking out, the threads are sticking out about a 1/4 inch, then that hole needs to be longer than a 1/4 inch, say at least 3/8, because you don't want the bolt to bottom out in the bottom of that hole. So you basically have to drill the hole deeper than the threads sticking out the bottom of the sensor so it doesn't affect your signal. And then once you put the sensor on the nice smooth surface you just created with these 3 tools, then you're going to need to torque that bolt down to about 15 foot-pounds. So it's nice and tight, and not too tight that you damage it, and not too loose that it doesn't work. So. And then here's just a couple of sensor pictures that were actually mounted. This one happened to be on a Waukesha, but you can see where they spot face the surface of that rough casting on the side of that cylinder to make it nice and smooth for that Bosch sensor there. And then, like I said, that bolt needs to be about 1 inch of thread, and 8mm by 1.25 is the bolt that you should get. And then you just got a quick weather pack connector to disconnect it or reconnect it or so forth. And then here's another one. And this happens to be a Waukesha also. And what we found that on the side of some of their cylinder heads, their cylinders on these Waukeshas, they actually had a 10mm thread. And it made it nice and easy if they just got this adapter that went from 10mm to 8mm. Obviously, the sensor is an 8mm bolt, and we actually have this. I don't know if we still stock it, Dave, but this was an Ultronic part at one time. And in any case, it makes life easy. You don't have to spot face nothing. You don't have to drill nothing. You just put this adapter in the 10mm hole, and then you screw the sensor into the 8mm hole, and life's easy. Now, this is what the Europeans like to do in a lot of cases. They don't like to drill into the engines. They get nervous. So this is what they do over there. They clean up the engine casting to make it nice and smooth, and then they actually glue that piece of metal to epoxy it to the cylinder, and then they put the 8mm bolt into that. And they claim that the glue that they use holds up and doesn't come off, and everything works great. And at one time we do know what glue they use, but I've never seen this done in the States, but that's what that is there. Okay, is there any questions on the DET that we can help you with? Okay, Mike, you want to take over? I'll stop sharing then.
Okay, I'll try to get mine up and running.
Paul, thanks very much.
Well, you're welcome.
Anything else for Paul on the DET system here? Obviously, a nice adder to really any ignition installation.
Paul, I would like if maybe you can do a brief comparison of why the DET 1600 is better, or the difference compared with the DSM from Waukesha.
Well, I'm not that familiar with the Waukesha product, John, so maybe if anybody out there is familiar with it and knows the differences.
The DSM from Waukesha?
Oh, you're talking about the one that we made for them?
Yep, the old one.
Yeah. This product, John, actually, I'm real familiar with it because being around it, and it works well. The Waukesha one, in a lot of cases I've seen that it's actually disconnected, and so I don't know, if they had that much trouble with it or what. But does anybody else have any input on that Waukesha one that's seen it work?
Mac, how many sensors do they use on the DSM, or what is it, 2 per bay or 1 per bay?
I'm not really that familiar with that Waukesha one, Dave. Like I said, the ones
sorry, I think that they are using one per cylinder.
Okay.
But what I heard in some point is that our system has the capability to get this window to monitoring the detonation in that specific window. But the DSM basically is trying to capture all the signals in the whole range, not on a single window. So that's basically creating bad signals or fake signals. That's something that I heard in some point.
John, one thing I can tell you that we've heard, and I know Joe and the rest of the guys were involved in the development of this many years ago, is that when the DSM functionality was really built to a spec provided by Waukesha here. So, in terms of us seeing any of the signal windowing or how that computation works, is somewhat of a Waukesha specific, intellectual property. We've not really seen that, so it's hard for us to really do a fair comparison here of how the two are operating, whether it's got the similar functionality to what's in the DET versus some other solution. So it's hard, I think, for any of us probably outside the Waukesha organization to give a good comparison.
Yeah, I heard it from Waukesha people in the field. In reality, that's what I heard. Besides that, they try to correct the detonation, retarding the time per cylinder, not globally. That's another difference.
Yep. Like we're seeing a gray screen right now.
A gray screen? Oh, sorry. I'm showing it really good here, so hold on. Still gray, Dave?
Yep, much better. Thank you.
It's working?
Yep. Before we move on with now it's not, Mike. Just went back to gray.
Oh, really? When I turned it.
So before we move on with Mike Porter here on the VSM, which is again shares a lot of commonality with the DET, any questions for Paul? Beyond, John, thanks for your question, certainly. But anything for Paul? Okay. Paul, thanks again very much. Good stuff.
Any discussion on the difference between the 1620 and the 1600? The wiring, the adapter module needed, the additional material.
Ken, I think we're going to end up going over that next week because I think we're going to cover the EVS, and that's supposed to be something that we're going to cover next week. So.
All right, no problem. I can hold off till then.
Okay.
Do you see that okay, Dave?
We can, yep.
As soon as I turn it on to on the slideshow to begin is when it goes gray. So, does that go gray now?
Yes, sir.
Okay.
I would just advance them manually, Mike. It looks fine just as you're showing.
Okay. As long as we can see that, I'll just run it this way then.
Yep.
Okay.
Thanks,
Well,
Paul.
everybody, I'm Mike Porter. I've been with Ultronic now for about 13 years, and even though the VSM really has nothing to do with our ignitions, with our 4 shows that we were presenting here, we got one more next week. We decided, since we use the same sensor as we do with the DET, we thought this would be a good adder to put in that because it's a nice vibration monitor, fairly low cost. I think it's a good add-on for people looking to monitor their vibration on their engines. So I've got a really short slide presentation here, and then I've actually got a live one on my laptop behind me that's tied to a DE3000 that we're going to go through and actually do a live demo on that. I'll be pushing buttons and going through screen by screen to show you how it works. So. But anyways, I wanted to go through this real quick and give you an idea of the system itself before we get that far. So, again, we have This here we show that we have two VSM 400. That means there's 4 channels. And then we have the 800, it's 8 channels. And then also along with this, we have a VSM Plus module that we have that does not have a display, but it has an Ethernet that you can plug into either a PLC or an HMI somewhere. That is another alternative if you want to stick it in the panel and you don't want all these multiple screens. So we're not going to talk too much about that today, but there's a lot of information on our website for that. So the display itself, it's our powder-coated aluminum housing that we've been using for years. Our 95 ignition and a lot of our products are set up that way. Basically the same footprint. It's got 8 keys on it, LCD display. And the range temperature-wise is a -40 to a +185. And it's certified through CSA, and it's a Class 1 Div 2 Group C and D hazardous locations. Again, we use the same sensor that we use for the DET. It's made by Bosch. It's been around for many, many years. It's been used in the automotive industry for a detonation sensor on their automobiles. We're back into the 70s, so it's been around a long time, very durable, lasts for a long, long time. So the system itself, compared to the DET, it runs between 10 to 32 volts of power. So you can run it on a 12-volt system if you wanted to, or a 24-volt system. It has RS-485 Modbus communication, so you could talk to it remotely from another location, or if you were going to do some custom lettering, you'll need to talk to it through the Modbus. So it's got a remote reset, so if it is out on location and the engine goes down and you want to restart it, you can remotely set it. You don't actually have to be at the station. So, and then it also has a lockout device hookup on it also. So when you start the engine up, you can hook it up to maybe a speed input, and it won't turn itself on until it's reached maybe a 200 RPM or something. So it sort of gets through you all the nuisance vibration noises an engine has during startup. So in the DE3000 that this is connected to, we are using that hookup on it. So the way it was set up. So. It's got 2 output switches. One's normally used for an alarm. You could set up an alarm reference number on it there. So if it triggers that, we could either turn on a light or a horn, or trigger a channel that would get fed back maybe through the DE, let you know that the system is an alarm. So you can maybe able to take care of it before you have a large mechanical failure on it. And then the other one would be used for a shutdown alarm on it. But I want to throw this out here because it's not that we recommend it, but it has been done before, is they actually had used this for a detonation device. They had some cats at one of our customers that tied the alarm or the switch 1 into one of our ignition system, a CPU 95, and they triggered our one-step ignition on it. So if the engine did go into a knocking noise, because at that point you couldn't tell if it was a knocking noise because the engine's coming apart or if it was actually detonation. Then they triggered switch 1, it would automatically open up a ground input to the ignition system, and then they would program the ignition to say if the input's grounded, back the ignition off 4 degrees. And then it's non-latching, so if the engine got out of this knocking noise, the ignition would go back. So that has been done by a few of our customers up north. But again, we would normally recommend the DET for that because it's got a lot more features for that, but it has been done. So again, this is a sensor. Paul's gone through most of that. So I won't spend a lot of time on it. The sensor's made by Bosch. The mounting idea is the same with what Paul went through on it. So you'd like to have a nice clean surface to put that on. So. And again, this is just another picture. In fact, this one in the corner is the same one Paul was showing you. Is how they mounted that. So. It has a wide range of uses. When I first started working, when this thing came out, Dave Bell asked me if I could come up with a list of how many places I could put this. And we had a CAT 3616 with a 6-throw compressors on it. And I actually went through and looked at different places, and I had over 100 some places that you could probably monitor vibration on it. Because, you know, my background's an end analyzer guy, and there's all these different spots we could put it on. So, I mean, it doesn't have to be tied directly to the engine. It can be cooling fans, electric motors, pumps. It has a wide range of uses to monitor vibration on it. So. This is one of the stations in Illinois. They have 3 White Superiors in there. We installed a DE 3000 in there, and then later on they upgraded to the VSM on it. So that was added into the panel, along with a bunch of other vibration devices. And as you can see in this picture here, we mounted this on the engine block. And then you can see we got an earthquake switch over here that they did leave in service for a while, just to make sure everything worked out well on it. So, and we mounted all these all over the engine. So, I got some other pictures along with that. So, this is on the other end of the engine here. This had a 4 to 20 output that ran into their PLC for the vibration below that, but we ran our sensor just above that for a backup and tied it to the into the DE. So. This is on a cylinder support on the compressor side. We were looking for an area that would have a lot of movement in it. So when the compressor started knocking because of a wrist pin maybe going bad or a crosshead pin, that we could pick it up in there. So, and we mounted those on each compressor cylinder. Same setup here, but on another type of cylinder. So, and then we mounted them on the cooling fans. This engine was the cooling fans were driven off belts off the front of the engine, and then went out the side of the building. And again, you can see another earthquake switch below next to that. And on engine number 3, there, as we were setting these systems up, we had the outside bearing or the outside of the cooling fan housing showed up probably twice as much vibration as the other ones did. And you know, we looked over the bearing and they greased the bearing. The bearing wasn't getting hot or nothing, so they decided. We just set the shutdown a little higher on that particular one. Well, this thing ran for probably about a year and a half. And finally that bearing got bad enough where they increased and it was triggered with this and shut it down. And so we picked that bearing up, noise of that bearing up a year or so before it actually failed. But at the time we didn't know any better to actually have it removed. So after they pulled the old bearing out and put the new bearing in, the vibration level went back down to normal again. And of course, we just readjust our alarms and shutdowns on that. So so they're very sensitive, and it worked out extremely well to figure out what that was. So. And now this is another option. We've only done this for one customer that didn't like the idea of having the wire hanging out here. They wanted everything in conduit. So with the help of Selzer and Ken Swilley, we actually come up with these conduit boxes, and we mounted a little plate in the bottom of it where you would normally tie your ground wires in. And then we mounted that on a crosshead. It's surprising enough, I mean, the bottom of this is fairly flat, and we had a couple bolt holes on both sides where we could bolt it down. The vibration actually increased on it, so we had a nice signal coming in, and the only thing we could sort of address it to was the idea that that plate is not mounted. It's mounted on pegs here, so it almost like it acts like this plate almost acts like a drum to amplify the noise a little bit. So I said the customer liked the idea because the sensor was out of place. It was rather costly because these boxes are rather expensive, but the idea behind it was if the sensor ever did go bad, you just have to replace the sensor again. You don't have to replace the whole housing. So that is an alternative. Again, we've only used it once at one station that didn't like the idea of having the wire hang out there. So, but I think they're still using it today. So, and at this same station, let me find my mouse here. We hooked the system up, and they were looking at it remotely, and they one of the engineers from one of the headquarters was looking at it, and they were skeptic about doing this to begin with, and they said, well, the system doesn't work because we have this one crosshead that's reading high vibration on it, and blah blah blah, you know. So, anyways, he made arrangements to have the facility shut down the engine because of that, because they couldn't figure out anything wrong. When this was a discharge valve in the cylinder, and as you can see the side of it there, it's cracked. So what it was is that the cage that held the valve in place was loose, and this valve was chattering inside the cage on it, not to the point where it was audible enough where it sounded like when you were in the engine room, like something was coming apart on it. But that sensor in that box picked that up enough where somebody about 400 miles away saw that, made the phone calls, and they shut the engine down, and they found that before it turned into something a lot worse. So, so they were quite happy with that, and they ended up purchasing enough to do the complete station with that. So, the other alternatives is not having any protection. This was on a 399 cat that my understanding ran for about 15 minutes, possibly. As you could see, the two valves dropped out of the head and fell into the cylinder and destroyed the engine, or at least destroyed the head and two pistons in the engine. And as you can see, the one in the lower right-hand corner there, the piston's totally gone. It was just shattered laying in the bottom of the crankcase. And then the other two pictures, you can see where the valve is actually embedded into the head on it. So, so it's, I mean, for this, the price of that vibration sensor would have been extremely cheap for that. So, this is a little bit of the wiring diagram on it. The next slide's a little larger for that. So, if you are going to talk to this through the RS-45, you're going to need a little black box from for the inverter to convert the 485 to 232. And then you can see over there on the right-hand side that how to set the switches up on it. I believe that's in our manual, so you don't have to write anything down here. So then on the other side here, I'm going to go to the next slide because it's blowing up here. You can see the remote reset. So you can reset this from another location. And then you've got the startup lockout. And again, we are using that with this demo that I have behind me here. What we're doing with that is we got it tied to the a speed input on the DE3000. So I don't remember exactly where the RPM is on it, but at 50 RPM, maybe this thing will actually unlatch itself and come into service. So it takes the so you don't get nuisance shutdown on it. It locks it out until it gets up and running. So voltage, again, like I say, it runs between 10 to 32 volts. And then we have the two output switches for usually an alarm and then a shutdown on it. So, and then for the Modbus communication on it, if you wanted to go in there and remote access all this information, that can be done from there. And then also, if you want to do some custom lettering for this channels, you need to go into the Modbus through one of our Modbus tools to get in there and then to look at the numbers on it. How the system works, again, we use a regular Bosch sensor on it, and then we set the alarms up, alarms and shutdown. We give them a range in there, and they're in the individual channels. They have their own alarms and own shutdowns. So you don't put like a master one in there, and hopefully you're going to fall in that. Each individual channel has their own settings on it. The alarm is normally tied to switch 1 to give you an indication that something is going on. Then we can either turn the strobe light on or a horn on, or we can bring it back into another channel on the DE, letting you know that something's going on. But then if it gets worse, then we're going to trigger switch 2. That also has a time delay on it, so that you can individual channels, so you can actually, in case you ran maybe some liquids through the compressor and then it cleared itself back up again. So it was just into shutdown mode for a little bit, and then it goes back to normal again. So again, that's your would be set up for your shutdown. So this is just a little bit on the channeling here for each channel. So again, we're going to go through that live here in just a few minutes. When it's up and running, and it's not armed, that's telling you we got some timers activated on it, that it's showing you a vibration level, but we haven't got into the shutdown mode of it yet, or into the switch 1 or switch 2 yet. So, and then you'll see the one that says timer of 60 seconds. That's letting you know that the system is on, but we for startup purposes, we're locking it out for 60 seconds. And again, that's the number you put in there yourself. It's adjustable. You can put it in for no seconds or up to 999 seconds, I believe. I don't remember for sure, but we'll figure that out. And then below that, then it says channel is armed. So that's letting you know all the timers have timed out and the channel's active. And if anything comes in that starts knocking, it will trigger switch 1 and 2 and shut the unit down. So. Again, all armed, that's telling you all the channels have cleared the timers, and they're all set up and ready to go. The one below that's telling you channel 1, it's an alarm on switch 1 came up. So at that point, you'd either turn the light on or a siren on, or indicated something to your DE3000 or 4000 or a PLC somewhere, letting you know that there's a knocking noise that has started. Then below that, we were in alarm, and then we're also in switch number 2. So at that point, switch number 2 could be on a timer for a few seconds before it actually shuts down, but it's going to be letting you know that it's passed through and it's at the shutdown stage. So the other one over there, bad sensor. Again, this is another deal that Paul talked about previously. We can put some lower limits in there for the bad sensor. So if it gets disconnected or unplugged, or if the sensor fails, we can trigger switch 1 to give you an alarm on it to let you know it's bad. And then switch 1 can be configured to the point where if it's latching or non-latching, it will lock in, and or if it's fail safe, then it will actually knock the engine down. So most cases, if it does have a bad sensor, people are normally letting the engine run. So just taking the alarm in without shutting it down. So. And then on the one on the bottom there, there's multiple alarms, and you'd want to hit the view alarm button, and then you can step through there to see what the alarms are on. And then at the end here, you've got the choice of looking at individual channels, or you hit the escape button, and then you can get the little bar graph like we showed you earlier with Paul on the DET. And that's sort of a nice thing because you can look at all the vibrations at the same time. And if you happen to get a high one here or there, then you can focus yourself on that particular channel. So. And then if you need to reset it, then you'll hit the reset button, and then you'll give you a choice, the arrows, whether or not a yes number or no indication if you want to reset it or not. So, and that will reset it, but it won't clear the alarms. You'll have to physically go to the alarm button to reset those or clear those. So, then you got in the setup portion of it there. We're going to go through that live up here, so I won't spend a lot of time on that. So, and then we'll go through that. And this is showing you how they set the alarms and shutdowns on that, and then the bad sensor. So, and we'll get into that here shortly. So, at the beginning there, when you get into the setup button, it's going to talk about auto scan, and you can set that up and how often you want to look at the channels. You can set it for 0 if you want them to lock in, just like the DET was, or you can put a timer in there. So in this case here, every 3 seconds, it's going to scan to the next channel, and just keep on doing that. And then if you get to the point where you are maybe changing it from one unit to another unit, and you want to go back to the factory settings on it, we allow you to do that by going in and pushing the setup button. It's going to go to auto scan, and then if you hit the reset button and the set point buttons at the same time, you'll get into the factory defaults, and then you'll use the up and down arrow keys to pick if you want to reset that or not. So then everything will go back to the factory on it. So. Then the filters, same thing what Paul talked about too with the DET. The higher that number is, the more filtered the number is, so it doesn't bounce around a lot. And normally I think it comes from the factory around 240, and normally that's where it stays at. But if you wanted it to be maybe a little more sensitive, you can lower that number down some. So. And then we got displays for the units or tenths. Unit shows you the whole number. Like if it's say it's 251, it's going to show you that. If you go to the tenths, it's going to say 250. There's always going to be a 0 at the end of the tenths one. So normally people leave it on the units, but you have that choice there. So then there's also in the setup there the number of channels. Again, the one we're going to be playing with is a 4-channel, and right now it's set up for 2 channels, but we have the choice of picking how many channels it is. And then if you get the VSM 800, then you've got 8 channels you can pick from. So, and then the channel labeling, we give you quite a variety of different labels that you can pick from, from engine vibration, compressor vibration, main bearing, and stuff like that. But we also have the option there if you want to do a custom labeling. This is something that Selzer did for us. Ken Swilly did this and this sort of gives you an idea how to set that up. You have to go into the RS-45 with Modbus tool, and as you get to these registers, this is for channel 1, and this is the information you would enter into that register for each of these channels, for each of these register numbers. And every time you change the lettering up here, like this is an S, T, G, these numbers here will change. And then when the final number, this number here, would get entered into this Modbus number, or Modbus number here. And then this information here would get in there into this. And then when you get done and bring the display up, it's going to read this stage 3 cylinder number 5 there. So it's a little spreadsheet that you could probably get with Ken Swilly, and he would set you up with that. So it works really well. The start delay, along with the idea we have a lockout that we can lock out with a DE, we also have a start delay in there too that we can put in there. So it gives you time to get the engine up and running online and get all the little knocks and everything out of it before the vibration device actually kicks in. So nice idea, because you can set your parameters a little tighter on it, not having to set them high because of all the things that happens beforehand. So, and then we also have a sensor gain on it that runs from 0.111 up to 0.2. and that just gives you the gain to get the numbers in the middle of the screen there. So again, this one here we're on, it doesn't vibrate very much, so I've got the numbers both set at 2.0 to give me high enough reading on it. So, and again, we'll go through that. The trip delay timer, we talked about a little bit earlier. We get into channel number 2, we get into shutdown number 2. We're going to allow this case here, we're going to allow it 3 seconds before we're going to shut the engine down. We're going to give the engine time enough to possibly clear the knock, whatever it might have been, before we actually kill the engine. So, and again, these are all adjustable. As you can see, channel 1 was set for 3 seconds and channel 2 was set for 6 seconds. So depending on what it was hooked up on, how critical it was, we can set a trip delay timer on that. And then the switches, switch 1, again, that would normally be our alarm switch. You have the choice of turning it on or off. And then you can have a fail safe or a shelf. The fail safe is basically designed for a safety. If you lose power to the device, it's going to trip and shut you down. The safe is set up to the point where, depending on how you have it programmed, it will stay active and just work off the information that gets off the device itself. So then also we have a latching and non-latching. Non-latching, if it triggers it, it will shut itself, or it will turn the alarm on, in this case being a switch 1. But if it gets out of the knocking area and goes back down to normal, it will reset itself. So again, depending on how you want that set up. So same thing with channel or switch number 2. Now, to get more information on this, if you're not aware of by now, we do have an app that will work for the Apple phones and the other one. And it says Ultronic on it here. And if you hit the app button, you'll get this page here. And you can either go to the Ultronic website or you can go to our GTI website. Hit the Ultronic one, you'll get all the technical documents. You can get in there, and then you'll find information like this. And this is also, you can find this on our website too, but you can get down there on the VSM and the DET, and you can look up our manuals on it. The nice thing about the app phone is, after you get this information, you can actually store it in your phone. So if you're out on a location that does not have a internet service, or you can't get the phone to get out of there, you can have that information stored on your phone. So, and I believe that is it. So anyways, give me just a couple seconds here, and I'll go from one computer to the next, and we'll do some live demos on it. Any questions at this point?
Mike, I just had 2 applications to mention on this. We put this on the wastewater treatment plant at the bottom of the hill in Girard by Ultronic. They had 4 water pumps and pumping, millions of gallons of water and stuff. The bearings would go bad and it'd be pretty expensive for them. So they basically got a VSM 400, and they put one on each of the pumps. So one sensor on each of the 4 pumps, and then they ran up the Modbus and they watched it on TV screen, and they actually could see when the bearings start to go bad by basically watching it on a TV screen. They actually had like I said, a VSM 400, but it was cheap for them, and they just loved it because after that they had no major failures of the bearings, because they would shut that particular pump down and replace the bearings prior to them completely going bad, because they could see it with this product. So cheap way to save a lot of money. And then another application where they used this was on blowers for some of their big engines at the Minion. And they said that every time they'd lose blower bearings, it would cost them $16,000. And after they put this VSM on and proved to work out showing the bearings were going bad prior to the major failure. It cost them $16,000. They actually went out and put one of these VSMs on every one of those engines with the blowers. I believe they were Coopers. In any case, 2 applications that this product just worked well for and really wasn't that expensive. So just wanted to throw that out there.
Thanks, Paul. Any other questions from anybody before we get started on this demo here? Hopefully everybody can see it well. Okay. What we're going to go through first is the setup button on it. So I'm going to push the setup. First thing comes up is auto scan. So right now I'm auto scanning the 2 channels I have set up every 7 seconds. So every time 7 seconds clicks, it will go and change to those channels. So what I'm going to do is lower that down a little bit. To 3 seconds. And if every time you make a change, you've got to hit the enter button to store it. Now I'm going to go back to the main screen. Now I say again, I have 2 channels out there, and you can see every 3 seconds that's going to jump from channel 1 to channel 2. So that's how that works. So back to the setup again. Hit the setup again. The filter on. I'm not going to change that any, but I explained that a little earlier. That's just going to stabilize the numbers you're looking at. Normally, I think it comes from the factory at 240. If you want the numbers to be a little more sensitive and move around a little more, you can lower that down. But normally, it stays at 240 on it. So I'm not going to leave that one alone. This is, again, we talked about the reference number. So right now it's in units. So I'm going to go back to the home screen again. And I don't know if this is going to work for us or not because I'm not on here yet. But anyways, in units, it's going to read the whole number. But if it was in tenths, it would read, in this case, if this happened to be 10, it would read like 1 here with a 0 on the end of it there. Or if it was reading like 15, it would say, it would just be a 0 there instead of reading the 15 on it. So, but I don't have. We can change that when we actually get up and running again. So, go back up to the setup again. Number of channels. Again, I have 2 channels. This is a VSM 400, so I got the options of going to 4. And that will you can set up 4 channels, but again, I only have 2. So we're going to leave it there. Hit the enter button. Channel labeling. So I'm going to hit the enter. This one here is called channel number 1, but if I wanted to change it, this is the custom one. This is if you wanted to go in with that Modbus tool and go to the register numbers, you can call this anything you want. This is a water pump, a turbo vibration, oil pump vibration. This is main bearings. Engine vibration front, opposite, left bank, right bank, engine vibration, cooler vibration, and different coolers numbers you can put in it. Again, these are all ones that come with it. So I'm just going to go back to channel 1, blower, channel 1. Now I'm going to hit the enter button again to save it. Channel 2, same type of deal. Start delay timers. Right now this is set up for 60 or for 20 seconds for the delay on channel 1. Channel 2 is set up the same. So after we get the engine running and get it online, it's going to take 20 seconds for it to activate the switches. Before you'll actually shut you down. So, sensor gain. Again, I told you earlier I was on 2 because I don't have a whole lot of vibration going on here. So I believe channel 1 and 2 are set at gains 2. That's a maximum for the most sensitive. And we'll, where the up and down arrow key is how you change that. Again, and that will be different on every application you're on, depending on how the sensor is mounted, and the lowest is 1.110. So that would be the least sensitive at all. So we're going to go back up to 2. Then we're going to save that. Again, if it's channel 2 is the same thing. Okay, trip delay. This is 5 seconds. And again, I explained that earlier. What the idea is, when we do go to switch number 2, it's going to take 5 seconds to shut the engine down. So it's giving itself time enough to clear itself before it actually knocks it down. And that will be that's the same for each channel. This and channel 2 is at 4 seconds. So again, up and down arrow keys, and you can pick the time on it. So output switch number 1. Do we want it on? We have the option of yes or no, and we're going to say yes. This is in the self. So this is a point where if you lose power to this, it won't shut the engine down. And the switches, everything will stay the same at this point. If you pick fail safe, if we lose power to this, and I think that's a good idea because we're using this to protect your engine. So in this case here, if you did lose power to this, it's going to shut the engine down on you. So because it's protecting itself. So now we got the latching or non-latching. Latching is, or non-latching is, if it goes into switch number 1 and the vibration clears itself back out, it will go back out and reset itself. If it goes into non-latch, or if it goes into latching, it's going to go in, lock itself in, and you'll physically have to come out and either reset it on the display, or you can do it remotely from the reset, or you can use the Modbus input to trigger it. Okay, now we're back to the auto scan again. So we've done everything we can on with the setup button. So I'm going to go to escape. I'm going to go to the set point. Select a channel. In this case here, the first thing comes up is the alarm. Again, since I have really low vibration with this demo, I have set the alarm to kick in at about 70. Oops, I'm pushing the wrong buttons here. Okay, then I got the shutdown at 100. So now it's going to alarm. Switch number 1 is going to kick in. Then it's going to shut down when it reaches 100 on switch number 2. So next one come up is a bad sensor. Now if it gets below 30, it's going to tell you I got a bad sensor. Now you have an option with that one. If you lower the numbers low enough, that turns the sensor off. Whoops. Why did it do that? Okay. So now the sensor's off, the bad sensor's off. It still works as far as shutting you down the alarm. It's just if the sensor goes bad, it's not going to trigger anything to let you know that. So, and I'm gonna put enter on that one. And then the setup again, if you want to go to channel 2. Oops. And then there's the same thing on channel 2. So you have to do that for every individual channel that you're on it. And being only set up 2 channels on this, it just brings you right back to one or the other on it. So. Let me go back to the setup here again. Data communication. If you want to talk to this with your laptop through the register numbers, you've got to get in here and make sure your laptop is at the same rate that this is. So this is in case of GNOME 1. And then bulk rate is 19200. And then you've got the choice of picking what you want for that. Now we also have a security in this. We have the general security on it. It can be on and off. We're going to turn it on. Oops. Now you can enter a number in that if you wanted to. After you set it up, people can look at it, but they can't change anything on it. So you could put in, if you leave it at 000, you're okay. But if you start sticking numbers in, you got to remember the numbers on it. So, so we're going to leave it that way because I don't want the password to go in it. So I'm going to say enter. And then we're back to channel 1, or back to the setup again. So what we're going to do now, unless you got any questions, before we go through, I'm going to turn the demo on, the DE3000 on, and then you're going to see the vibration comes up, and then we're going to bang on the side of the case here a little bit and trip it. So right now everything's armed, but after we restart the demo on it, it will reset itself. So. We got the preloop on. I'm going to reset it. Now we would see where the timer came on now. So now it's giving the time itself to get everything leveled out before it comes active again. So we'll still jump back between channel 1 and channel 2. So now everything's armed. Now we're going to have a thing start coming apart on us. Oh, we got an alarm. We got a problem. Oh, you got a shut down here too. So we want to view. As you can see, it didn't shut down because it didn't bang long enough for that timer to shut it off. So we're going to go up here and view. And it says channel 2 was an alarm. It alarmed itself 3 times. We want to clear the memory on it. Yes, we do. And now we're going to see if we can shut it down. See, it switched number 1 and number 2. Now we just saved ourselves thousands of dollars worth of broken parts. We want to view the alarms because we don't know what happened. And it says channel 1 shut us down. We have some other alarms in there also. Channel 2 shut us down. Channel 2 alarmed. And channel 1 alarmed. So all it collects all that information until you actually clear the alarm. So hit the enter button. So now we're back ready to go again. Anyways, any questions?
Yeah, I have one, Mike.
I was afraid of that.
What was you beating on our demo to get it to go into vibration like that?
I have a picture of your face on the display, and I was just beating up. I knocked your nose off, so. Anyways, that's it for us. We're just about out of time. We got 15 minutes worth of questions. If anybody wants to add anything to either one of the devices, or if you would like to have more information on it, please email either Paula and I, and we can get you what you need. So, or Kenneth, if you're looking to maybe get that spreadsheet on the custom labeling on it. So, it's a little Excel sheet. So,
Good stuff, Mike. Questions for Mr. Porter on VSM, or even back to Paul on the DET series? As we said, we're going to have some additional content here related to next week, as far as how they're further interfaced with the ignitions and so on. So more on this to come, but based on what you've seen today in terms of the setup, and Mike, this was really effective here, I think, showing the unit live. So give a good flavor for that, and even certainly how the DET is set up. But anyway, questions for Mike or for Paul? Going once, going twice.
Has any technical bulletins been written on the wastewater plant that y'all added a VSM to?
No, it was never no write-ups. Ken, but basically it was just large water pumps being turned by 50 horsepower electric motors, and they put one sensor on top of each one of those water pumps, and like I said, the guy was somebody I used to work with in engineering down at the hospital, and he was able to take the information via the communications port and put it up on a large TV screen up in his like maintenance office. So they could actually see the vibration on this like a flat screen TV, like a pretty large one, and he had different informations on the screen, but 4 of them were the pump vibrations. So it worked out well for him, and it's not very expensive product, so he was real happy.
so next
Yeah, I
week,
could
everybody.
see where that would be effective.
So next Friday, everybody, we're going to go through the CPU 2000 and sort of get the 95 and run in that too. Then we also have some installation pictures of replacing the cat ignition for the under valve cover coils. We've got some slides we're going to put together on that and how we did that on an application. So that's our goal for next Friday. So.
Folks, anything else for Mike or for Paul? Any other questions? As usual, guys, well done. Many thanks here for the good, thorough review. Anything for our folks?
Possibly, Dave. I have a question on
Go ahead, Ken.
any correlation to the vibration from the uh, output of the sensor to inches per second. In selling them, that's what we run across the most is engineers stuck in his head with inches per second measurement and want it to be a known measurement. Is there any correlation between the two?
He's looking for units.
You want the display to do that, or you want to? We have a PowerPoint that has that with a metric vibration device, and we have a graph that shows ours running next to that. That's available.
Yeah, that's the biggest hurdle we run across is when you're talking to a group of engineers, their first question is what unit of measure is.
Right.
So my understanding is that Bosch sensor is basically a microphone, so it's picking up vibration. It's not an accelerometer like the metrics is. So the metrics can record and output inches per second, but the Bosch is really just a transducer. Does that sound right?
Yeah, Alex, you're pretty much spot on with that. This is Matt Trainer, by the way. So the way that's picking up the vibration, generally an accelerometer will have some sort of G force to it, to where this is actually just creating a piezoelectric signal that is fairly non-linear, and it's repeatable, but not necessarily extremely accurate to say something that is an accelerometer that's sensing G's like you're taking off in a plane. This is more of a, it's creating almost like a signal as if like a thermocouple would. So the harder you press on it as a piezoelectric, the more signal you get. The problem with that is it's not necessarily tuned to an exact frequency or peak movement. So G's have a couple different components to it, to where this is only really demonstrating one. So when you get into accelerometers and the math that you have to get into to take all that and extract the data out, you get into some pretty expensive sensors there. And Alex, you're quite familiar with the metrics and what we did on GTI. So what I could say is that there's a couple things. The first one is that this is used in the automotive industry, and we've been able to take high advantage of that for the cost. So if you want inches per second, the cost per point is going to go way up, because even for anyone to make a hardened solution, and there's quite a few out there, you're talking about several hundreds of dollars per sensor, even upwards of $1,000 per point. And that's just buying the sensor with no VSM or DET associated with it. So that's kind of where we're at in terms of saying we want inches per second. So if someone was willing to pay $1,000 per point, then just in sensor technology, it's definitely possible. There's probably, with cell phones and accelerometers now, there's other options, but to get it in the package that fits on the engine is generally where a lot of the cost comes from as well. But the other token to this is every car that you buy within the last 10 to 15 years all have this same sensor and are doing essentially the same exact thing as us, and it's working to sense all kinds of things within every automaker, from Volvo to Volkswagen to GM to Ford. So I don't know I understand engineers want to have some sort of unit, but They figured out how to do it in the automotive realm, especially at that low of a cost. So that's kind of where we're going and where we have been with it. But if you wanted inches per second, the cost essentially is what would drive and did drive a lot of why it is the way it is today. So Mike mentioned we have some sort of correlation. So you could say it's maybe this inches per second or that inches per second. But the best thing we can say right now is that it's experience and relative information and tuning it to your engine such that the parameters are, you look for it to go up or down, and then it's a relative measurement. But that's, again, at the cost point we have and the technology that's available, it's pretty robust and capable of doing what we need it to do. Hopefully that answers your question, and just piggybacking off of Alex there, that he's exactly right, that one's way more sophisticated than the other.
Yes, that answers it.